To further understand what the sender-receiver system has to offer, let's create a button which does a couple of things in the level when pressed. But before that, let's first upgrade the Godot project to the latest version of ReuseLogic Nexus add-on for Godot 4.2. Yeah, there is an update. Nothing is perfect and will never be. For now, the latest version is not released, so I downloaded it from the main source. Keep it in mind that in this video I used the version 0.11 beta. You may need to download it from the releases section based on when you are viewing this video. You also need the third version of the character controller example. So let's download that one as well. Before doing any upgrades, make a backup of your project. Godot sometimes does funny things when the files change. Now replace the files in the add-on. And just in case you don't have an example folder, simply make one and add the files to it. Make sure to name the folders as expected. Reload the project and run the game to make sure everything is working properly. The very first addition to ReuseLogic Nexus is the register signal function in the brain node. You can now simply pass the signal picker and the callable to the function and it will do the job internally. The second addition is a signal picker sibling property. This one searches the direct children of its direct parent and populates the list based on the first brain call. It helps you better manage your node hierarchy. You don't need to make everything a child of the brain node anymore. The final change is that both the sender and the receiver nodes clear the data dictionary before sending it to their target object. You may wonder why I'm doing this, because there may exist unnecessary information in the data dictionary based on the internal implementation of each object, and there is no reason to pass them to an external object. The coin has no reason to know what the state of the player is, and in fact overwriting such data may cause unexpected behavior in the external object if a conflict happens. Of course, data sharing is another aspect of OOP design, and I'll discuss it in details in a future video. Getting to work, it's now time to add the button. Let's add an area 3D with the shape of a button. This is just like what we did for the coin. Just like the coin and the diamond, we need a sender type for our button. And we need to utilize the sender node when the body inter signal is emitted. Attach a script to the root node and connect the signal. I expect you to have watched the previous tutorials, but there is a difference here. The button is pressed by the player, but it toggles other objects, not the player. So there are two relations here, player button and button toggables. If you want the button to be pressed only by the player or by some specific group of objects, you don't need to use the sender-receiver system, because we don't want to decouple anything in the player from the button. Simply use Godot groups or collision layers to handle player-button relation. For the toggables, we need to add a receiver sensitive to the button type, and we do need to use sender-receiver system here, because each toggable object needs to perform some specific internal logic when togglers are pressed, and the sender-receiver system helps us decouple that internal logic from the button or any other toggler system. Let's add a door. Choose Mesh Instance 3D as the root node. This is just a demonstration, not a real door. Adding the brain and the receiver node, attach some script to the door. We need a toggle signal in the brain. Make the receiver sensitive to the button type and make it emit toggle signal when the button sender does its job. Inside the door script, let's add some opening and closing mechanism. Of course, you can go fancy and add opened, closed, opening and closing signals to the brain and make the door use a signal-driven state machine. But I'm just using a boolean here to keep it simple. Don't forget to select the toggle signal in the doors inspector. Placing a button and a bunch of doors in the level, we now need to tell the button which doors to toggle. Add an array of nodes to the button script. We can now iterate through the array and make the sender do its job for each one of them. Back to the level, let's make the button toggle the first and the last doors. It is working as expected. Add another button and make it toggle the second and the third doors. Now here's the thing, you can add a sender of type button to anything and target anything sensitive to the button type, and it will work as expected. Let's make the diamond sensitive to the button type, and let's make one of the buttons toggle some diamonds as well. Of course, we get an error if we try to toggle a freed object, so we need to do some check before utilizing the sender inside the button. I hope you see how powerful and time-saving this approach is. If you had implemented the objects in the non-OOP ways, you'd have to modify the diamond script to make it react to the button. By maintaining OOP principles and utilizing reusable modules, you don't need to keep reinventing the wheels. In such a simple system, this may not seem to be a great deal, but in the long run, when things get complex, this is the way to go. Thank you for watching and stay tuned for what's coming next.